Okay, year 13, I am going to try and use my bike to help me explain this question here. Do you know in the exam questions where it asks you to explain this graph? So this graph here has moment plotted against angle. So see the way I have the pedal positioned there? That is what they're taking as an angle of 0. So all angles are measured in this from this vertical position. And then I'll just rotate them around. That would be an angle of 90. And then down here would be 180, 270 and 360. Right? So I'm going to explain why the graph is that shape here. Now, throughout this question, and I think they had drawn the wee arrow on, but throughout this question, they're taking it as if, which is probably true, the force acting from your foot is always acting vertically down the way. So at this position here, which they have 0 degrees, if your force is acting vertically downwards, then the distance that you're going to need for the moment has to be horizontal, because remember the force and the distance have to be perpendicular to each other. So if your force is acting straight down here, right, that way, then it's going to be creating 0 moment, because the distance to the pivot, which is this wee point here that it's rotating around, is 0. Now, as you start to pedal and push around here, right, so let's say the pedal's there, then your foot is pushing down here vertically. The horizontal distance has increased as that pedal has gone round. I think my hand keeps putting this out of focus, but if we look there, the horizontal distance from where the force is acting to the pivot, I'm trying to show there with my finger and my thumb, is about that much. As this goes on round, then that distance keeps increasing. So the maximum distance that you can possibly be here is going to be the length of this crank here. So in this position, which was the 90 degrees, it's the maximum moment. So if we look back up at the wee graph, right, so 0, 90 is where the maximum moment is. Now see the way it's not linear, it's not a straight line. That's because the distance doesn't increase linearly. So if you're thinking about the horizontal distance, right, I'm trying to get level to show this properly. See, whenever we're going from here to here, the horizontal change in distance is quite big, and that equates to that steep, that steep first bit of the graph, because as this is going around, the horizontal distance is increasing like quite quickly. So that means the moment's going to be increasing. But then see, whenever you get over here, like from here to the 90 degree position, that horizontal distance barely changes at all, which is why we've got this curve. So the further away you get from it, basically, the amount it's changing by decreases. It's still increasing, but it's not increasing by as much. Now, on the way down then, it's like the same but opposite. So let's go through that. So as this is going down, our horizontal distance, so between where you're applying your force here, the pivot here, our horizontal distance is decreasing round to 180, and we're back to 0 again there because the distance is 0. Now, from 180 to 360, the graph, it kind of looks like they've stopped drawing it, but they have. It's just that the moment is 0 the entire time, because your foot on the way up is not applying force. The other foot is applying a force, but this is only talking about the moment that's being created by this one. So on its way up, there's no force, so there's no moment. Okay, hopefully that has helped a little bit with that graph. Okay, bye.